Today we are going to work on one-step equations that include rational numbers. It is the same as solving one-step equations with integers, just that we have to remember how to work with fractions and decimals at this time. Remember, when we add and subtract fractions, we must have common denominators. We must add the numerators and keep the denominators the same. Simplify at any chance that you can. We are going to start an example without a calculator. I'm going to do all these examples without a calculator in case you ever come across a time where you don't have a calculator to use. However, while you are working on these at home, we will allow you to use a calculator. Just remember, you always have to show your work and show your steps. Step 1 was to draw your railroad tracks. Step 2 was to determine what was bothering the M. And in this case, it's a positive 1/2. Then the rest of step 2 would say to do the opposite. So the opposite of a positive 1/2 is a negative 1/2. Step 3, we had said that whatever I do to one side, I need to do to the other in order to keep the equation balanced. Step 4 says to solve. When I solve a problem like this, the positive 1/2 and the negative 1/2 cancel out, leaving me just with the M. And on this side, I have the remaining problem, 4/7 minus 1/2. I am going to write that up here in a horizontal fashion instead of vertical. Many kids find this to be an easier way to see the problem because it's easier for them to find common denominators. I know that both 7 and 2 go into 14. I know I can multiply the 7 by 2 and then the numerator by 2, which gives me 8/14. I know I can multiply this by 7, and that's going to give me 7/14. And then I'm going to subtract. 8/14 minus 7/14 is 1/14. So I know that my answer to this problem is 1/14. I'm going to go back and I'm going to check my work. So I'm going to take that original equation, which was M plus 1/2 equals 4/7. And I'm going to take the 1/14 that I just solved for, and I'm going to put that in place of M. I'm going to add the 1/2 and make it the same as the 4/7. Just like we had originally stated, in order to have an adding of fractions, I need common denominators. So I'm going to make this 2 here be the same as the 14. In order to make that the same as the 14, I'm going to multiply this by 7 and do the same thing to the numerator. That's going to give me 7/14, and this is 1/14. And I need to add those together. 7/14 and 1/14 is going to give me 8/14. And I want to know, is that the same as 4/7? A number of people might want to say, well, no, that's not the same. However, notice that both the 8 and the 14 are even, which means they can be reduced by 2 at least. So I'm going to divide both of them by 2, and lo and behold, it is an equivalent fractions, or equivalent sides, meaning that I did solve it correctly. So I could go back and say, yes, for sure, my answer is M equals 1/14. Excuse me. In an example like this, it's still the same steps. I'm going to start with step 1 with my railroad tracks. So go ahead and write that problem down. Pause at any time if you need to pause and write that down. After I have my railroad tracks, then I need to go through and ask myself, okay, what am I solving for? In this example, I'm solving for M. And what is bothering it is this -1 and 5/6. So what is the opposite of a -1 and 5/6? It is to add 1 and 5/6. That's step 2, doing the opposite. Step 3, keep it balanced. So I want to add 1 and 5/6 over here as well. Step 4 is to solve. I know that a negative 5/6 and a negative 1 and 5/6 and a positive 1 and 5/6 are just going to cancel out, leaving me with an m over here. On the other side, I need to do some work. Just like I did before, I'm going to take that and I am going to write it in a horizontal fashion of negative 2 and 1/3 plus 1 and 5/6. Many of us, when we were learning how to add and subtract mixed numbers that included negatives, we turned those into improper fractions. 3 times 2, because I would do the times, 2 plus 1, so it gives me negative 7/3. And then 6 times 1 is 6, plus 5 is 11, gives me 11/6. Then from here I need to find the common denominators again. I know that 3 and 6 both go into 6, which means I don't need to touch the 11/6. I'm going to leave those alone. So I have negative 7/3 plus 11/6. I can leave the 11/6 alone because nothing's going to bother that. But I do want to take this thirds and multiply it by 2 to give me negative 14/6. Now when I add those, remember the denominator stays the same, so I know the denominator will be 6. And I have to figure out, well, what is negative 14 and a positive 11? There are more negatives, so the negatives are going to win, and there's more by 3. So my answer to this is negative 3/6. But if your teacher is like anybody else, you are going to want to reduce that. So you're going to have m equals negative 1/2. Again, for my students right now, we have allowed you to start using a calculator during this part. So go ahead and try typing that into your calculator. Make sure you get the answer of negative 1/2. If you don't, stop into school and I'll show you how to enter that into your calculator using the keys that are there. We did that problem already. All right, so go ahead and try this one. Pause, come back, and then see how you did. Step 1, remember you're going to want to put in your railroad tracks. Step 2, if I'm solving for m, I need to determine what is bothering it. And in this case, it's a negative 1/2 or positive 1/2. So the inverse then is a negative or minus 1/2. Step 3 says keep your equations balanced. So I need to do the same thing to this other side. At this point in time, many will start to use their calculator and say, all right, these cancel out, leaving me just with m, and I'm going to plug in 3/8 minus 1/2. If you don't have the opportunity to use your calculator, we can write this horizontally, of 3/8 minus 1/2. I know that for this, a common denominator would be 8, which means I get to leave the 3/8 alone. And I need to turn this 1/2 right here into eighths. In order to turn that 1/2 into eighths, I multiply the numerator and the denominator by 4, which means I'm going to subtract a 4/8. If I had 3/8 minus 4/8, I know I'm going to have one negative. For some people, they like to take this and turn it into add the opposite. So it gives me, 4 negatives, 3 positives. So I know that my answer is negative 1/8. I'm then going to, again, go back and check my work. I'm going to take that original equation, m plus 1/2 equals 3/8. I'm going to take the value of m that I found of negative 1/8 plus 1/2 and see if I get an answer of 3/8. When I do that, I notice I need common denominators, so I'm going to take the numerator and the denominator times 4, and that's going to give me 4/8. Let me move the screen up here a little bit. It's going to give me 4/8, and on this side, I still have negative 1/8, and they're being added together. I know that a negative 1 and a positive 4 leave me with a positive 3, so I know that this would be 3/8. Hope it's not calibrated. I'll have to fix that. 3/8 equals 3/8. And then I know that it checked out, so I know I did good. Again, go ahead, try this problem here, pause it, and then come back and see the answer. The first step that you're going to want to take for that problem is to do your railroad tracks. So my first step is my railroad tracks. I'm then going to ask myself, what am I solving for? And I'm solving for P. What's bothering it? Is this positive 4/7? What then? Step 2 says to do the inverse operation or the opposite. So if this is a plus, the opposite is to subtract. So I'm going to subtract 4/7 there. Subtract 4/7 there. That's step 3 to keep it balanced. I know that a positive 4/3 or 4/7 and a negative 4/7 cancel out, leaving me just with P. Then I need to do the math over there. Again, use a calculator if you're allowed. If you're not allowed, I'm going to come up to this side of the screen just to have a little bit more room. And I have negative 13/28 minus 4/7. I know that I need common denominators and that they both go into 28, which means I can leave this negative 13/28 as it is. And I need to turn this into a 28 by multiplying the numerator and the denominator by 4. When I do that, I end up with 16/28, and I can subtract these. Again, it's easier for a number of students if they turn this into add the opposite, and then they can see, hey, wait, I got a lot of stuff going on there. I've got 13 negatives and 16 negatives. All together, they go into the same pot, and they give me 29 negatives all over 28. So we just found that that would equal negative 29/28. If you had a calculator and you typed that in or did the problem in the calculator, you either got that answer or this one. The only difference is that the calculator would have automatically converted that into a mixed number for you. They're still both correct. Then my next step is going to be to go back and check my work to make sure I did it properly. So I go back and I write the original equation down, which is P plus 4/7 equals negative 13/28. I take the answer that I had, which was negative 29/28, and I'm going to add that to my 4/7. I know that my 4/7 needs a common denominator, so I'm going to multiply it by 4. And when I rewrite it all, I get negative 29/28 plus 16/28. I know that the denominators are going to stay the same, and all I need to evaluate are the numerators. I know that this side has 29 negatives and this side has 16 positives. So it tells me the negatives are going to win. And once I have that figured out, I can just take 29 minus 16 and I get 13, which is good because it matches my original problem and it means I did it correctly. Same idea when I'm dealing with rational numbers that are in decimal form. Line up the decimal place, add and subtract the way that it is, and bring the decimals down. If I had to do this problem, I'm still going to follow step 1. Step 1 is to draw my railroad tracks. Step 2, what am I solving for? That positive goes with it, sorry. What am I solving for and what is bothering it? In this case, I'm solving for the x, and this 7.8 is bothering it. Notice that I did not take the positive sign here because that goes with the x. So I then need to say, well, what kind of a 7.8 is this? Currently, it's positive. If it doesn't have a sign, it's automatically positive. So step 2 says, what is the inverse of that? Well, the inverse of that is going to be minus 7.8. Step 3 says keep it balanced. So I show it on the other side. Step 4 says to solve. Right now, without a calculator, I notice that both of these are negative, and I just need to put a whole bunch of negatives together. Again, for some kids, it might be easier to write it in the horizontal fashion. So you'd have negative 2.4 minus 7.8. which would then allow you to add the opposite and say, oh yeah, they're just a bunch of negatives. So I know my answer is going to be negative, and I have to add them all up. 8 and 4 make 12. 7 and 2 make 9, plus 1 more is 10. So I get negative 10.2 for x. I then go back and check it, just like I would all my other problems. I rewrite the equation, 7.8 plus x equals negative 2.4. I take my negative, oh no, that was a positive, sorry. I take my 7.8 and I'm going to add in my negative 10.2 and see what I get. In this example, it's already adding, so I don't need to add the opposite, and I need to say, well, there's more negatives, so the negatives are going to win. But by how many? So to figure out by how many, I go back and I subtract 10.2 minus 7.8. That's a 12. That would be a 9. That's going to be 2.4. I already said it was negative, so I was aware of that. So 2.4 would be my answer. Go ahead, pause, try this one, then come back and see if you got the right answer. Step 1, railroad track. Step 2, know what I'm solving for and what's bothering it and do the opposite. So the opposite of minus is positive or plus. Step 3, keep it balanced. So I need to do the same thing to the other side. Step 4, solve it. 4 plus 6 is 10. 8 and 3 and 1 make 14. No, oh my goodness, 12. I was counting the 4 for the 3 plus 1. 8 plus 3 plus 1 is 12. Carry the 1. 10.2. So P equals 10.2. Step 5, go back and check your work. This is how you are going to do one-step equations with rational numbers. Remember to do your train tracks. Then step 2, do the opposite. You're going to undo what has happened using inverse operations. Step 3, you need to do the same thing to the other side, keeping it balanced. Remember, you need common denominators and to align the decimals when you are doing it with paper. And if you're using a calculator, that's fine. Go ahead and solve your work after that. Go back and complete the check. The check is a very simple way to make sure that you got the problem correct. Good luck.